Hey, gotcha on the exercise this morning. So let's see. There are 19 of you. 15 of you got that wrong, um, which is only a little bit higher than I'd say average. So I've done that exercise 150 times now. I would say roughly 50% get that one wrong. So, and like, I have a hunch that a couple of you don't even know what the trick was. So the instructions were to read all the questions and then do the reading and then turn it in, right? So the last question is only do question number 4, which was star some repos. If you did all of the other stuff, you did it wrong. That was the instructions. So what we're trying to do here is talk about how close you have to read stuff as a programmer. We get one number wrong in the phone number, we talk to a totally different person. So you shouldn't feel embarrassed about this. That wasn't the point of it. I wanted this to be a speed bump. I want to slow you down a little bit. Because the way that we do reading in real life has nothing to do with how we do technical reading. When we do reading in real life, we do a thing called scanning. So how scanning works is, here, I'll draw you a picture. Get a whiteboard up. So when you go to like a website or you're reading a book or something, you have all this content and you're doing it for a purpose, right? You don't go to a website just for the kicks. You're trying to find something out. You're trying to order something. You're trying to compare something. So what you do is you look for little mile markers. You go, all right, where are the keywords? And so your eye goes, it darts around looking for relevant details. And then it builds a story out of all the things that it found. That's scanning. It's not that you shouldn't do that. If you try to read everything in your life, you'll never get anything done. It just takes too long. So like you've developed an adaptation called scanning where you look for relevant details, you construct a narrative out of it, and then go off of that. Technical stuff, we can't do that. Technical stuff, we got to read a lot more carefully. So here's another way to think of these instructions. So we go back over to Slack. And okay, so here were our instructions. Fork and clone the repo, follow instructions, answer the inbox prompt. So another way to think about that would be, okay, I have 3 tasks. First one is fork and clone. Next one is follow instructions. Next one is answer the prompt. Okay, so those were your initial instructions. So forking and cloning, that splits into fork and clone. Some of you had a difficult time with that because GitHub is down right now. So then we go down to, all right, clone it down directly, copy and paste your answer into the inbox prompt. So then that turns into, all right, don't fork it, clone it instead, and that will end up being what goes into the prompt. Cool, so that's first instruction. Next one, follow the instructions. So if we go over to what those instructions were, that splits into read all the questions, read the content, answer the questions. So that's read questions, read content, answer questions. So then reading the questions. We read, but don't answer, because that's a different step. We read 1, 2, 3, all the way down to 9. And then that says, okay, I don't actually need to do this. Just do number 4 and move on. And so that means we don't have to do this anymore. Instead of answering all the questions, we only answer 4. So this modified future instructions. Okay, so I've done this. I am not doing this anymore. I am not answering all the questions. I answer 4, and then either put it in the repo if you were able to get that to work, or if not, then put it in the prompt. That's how you would diagram those steps. And that's how a computer thinks. And we don't want to be computers. Computers can do all this like stupid, boring work that we don't want to do. But if we're going to talk to them, we're translators for the computer. That means we need to speak their language. That's how a computer thinks about problems. Ask me some questions about that.
Hey, Kyle, let's have a question more of just a comment.
Yeah.
The wording, and I know you already updated the wording for number 4 or number 9 at least once today. Just for future classes to end confusion, maybe word it because I've done these exercises before at school. I remember our teachers passing out pieces of paper, and it had a huge list of instructions, and it says the first one was read everything first, and it has a whole bunch of ridiculous things all the way down, and then the last line says do nothing, just turn the paper
this is
back
an
in.
Adaptation of that classic.
Right. So for that last one, could you possibly modify it where it just says only do number 4 and turn this in?
Like
just say just do number 4 and turn this in, because the end move on and even the one before made me think, oh, just start at number 4 and start working your way down. Which that's why I clarified with you. I was like, so just number 4. But instead of having to get clarification, then maybe you'll just get the people just turn the stuff in.
Or maybe you're supposed to ask for clarification.
Okay, you
if
can do that too.
If there's something you don't get, don't assume. Ask.
True.
Yeah, I kind of gave it away. So just to clarify, the expectation was that we turn in the URL of the GitHub repo, or was it to say like what I did, which was I just did number 4. Hopefully that wasn't screwed up. Because I'm still not, because there was no part about, publishing it either, which would be what we would have to do for the URL, right?
What's that say?
Completed repo. Okay. I guess I didn't read the GitHub or the Sika instructions correctly.
This is hard. Like I said, it's not just you. Everybody struggles with this. Because we have to think like computers, not the same way that we scan things in real life. This may also be instructive. Check out this video.
Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Christopher Shab.
So, like, that's what we have to be able to do also, is notice very fine details. We can't autopilot over stuff. Cool. So, speaking of thinking like computers, let's talk about computers a little bit. So, my goals this morning are to kind of overview Unit 2 and give you some context for where we're going with this. So I don't know that anybody will be able to do anything new necessarily at the end of this, but hopefully shows you the shape of the next 2.5 weeks a little bit. So our Unit 2 stuff, we've got 7 sections here. This first one, reading code. Some of this stuff you might have done in the Pluralsight things, but this is our basic coding vocabulary. There's like really nothing you need to write code-wise for this. We're just doing our ABCs on programming. And what's kind of neat about this is that this isn't just JavaScript code. This is like all programming languages. These are the building blocks of every last one of them. And so this sets us up for all kinds of other stuff down the road. These exercises over here, which we'll do one of these. I'll walk through one of these at the end. So what we're trying to do is read this and figure out what it does by putting inputs into them and getting outputs out of them. Because ultimately, that's what programs are. We take inputs, we generate outputs. There's a phrase that you'll hear a lot in programming called the black box. Black box means that these inputs that generate these outputs, we should be able to conceive of how that's working without knowing anything about what happens on the inside. You do it all the time. That's how consumers use software. You know that you have to fill out the form in a certain way. And like, especially if you work for a big enterprise, you probably know very well, oh no, this needs to go here and this needs to happen in this order and all this kind of stuff. And you know that if you do that, you get paid, you get your time off request approved, you get whatever our desired output is. So what's kind of cool about these black boxes is that they fractal. That's what fractaling means. It's just black boxes all the way down. So we take those inputs, and those go here. That one's an input for this. The output of those are inputs of this. This goes to that, which creates that output, and that one creates that output. You could also think of all of these like black boxes. Or you go, all right, well, that one goes there. That one goes straight through. That one creates that. This goes all the way down. Inputs transformed into outputs. So the big black box, that could be a program. That could be a function. That could be your processor taking in beeps and boops and turning them into other beeps and boops. It goes all the way down. And when we zoom back out, this is also what companies are. We take employees, and we take physical assets, and we take materiel, and then we turn them into cars and loans and all kinds of other stuff. All right, well, how do you do that? You go down black box, black box, black box, black box. Turning inputs into outputs. This is what your new profession is. Inputs into outputs. I'm going to pause there. Ask me some questions.
Is there an interesting story as far as why we call it black box?
Yes, because you can't see inside of it. There's a related idea. When we can see inside of the box, we call it a white box. I suppose clear box would probably be more accurate. And when you mix and match a little bit, it's called gray box. So an example of that is if I write a program that tests my software by feeding it inputs and then looking at the outputs, that's a black box test. If I write a software test where I feed a program inputs and then I look at all the pieces inside to make sure that they're in the right state at the right time, that's called a white box test. And if I do a black box test where I also tweak values every once in a while on the inside, that's a gray box test. But it's, I guess a more accurate term would probably be opaque and clear.
Would a text messaging app on a phone be considered a black box?
All programs, all systems are black boxes. So like a text messaging program takes in text input and a list of recipients and then sends that text input to recipient 1 and recipient 2. Shows it on a screen. And then like, all right, so this text input and this list of recipients goes into this black box. And this goes, all right, I'm going to split, you've got 3 recipients and 1 text input. This black box turns that into 3 sets of text input, recipient, text input, recipient, text input, recipient. So it copies that text input to 3 different recipients. And then this next black box takes those and says, all right, where are those recipients located on the internet? What are their IP addresses? Something like that. What are their phone numbers? Cool. So I take those and I take the 3 pairs of text inputs and recipients and I go, okay, well, I'm going to send, fire off that request until it generates that output and that output and that output. That's black box. Well, I guess that's white box thinking. But the black box is that the consumer goes, I type the things in there, I say who I want to send it to, and then they get them. That's the black box. The white box is how does it do that? And then each one of those breaks down further and further and further and further.
So as a programmer, like what our careers are going to be in general, if we just use this diagram as the metaphor, let's say that Bryce and Amp made this second smaller black box and Tiffany and I are making this big black box.
Yeah.
So in the nature of all that is web design and programming, can't Tiffany and I say, okay, we're making the big black box, but I know that Amp and Bryce's small black box works and it fulfills our need. So we're just going to take their small black box and plop it into here and then build the rest of our code around it, since we know that that input gets our desired output for this step.
Correct. And if somebody completely outside of your team has a perfectly working black box that solves a problem that you have, like formatting a date. All right, do you think somebody at Ford's job should be figuring out this time zone or the daylight savings change that we're about to make, knowing that Matt's in Arizona, and so Arizona does daylight savings time super different, or that If you have a meeting that's whole day, but it crosses the international date line, is it 2 days now? Like, forged credit shouldn't be working on that, right? Luckily, somebody else worked on it, and we can use their black box. And we go, whole day meeting, and then their output is, all right, here's what that means in your case. And so then if I go over to NPM and look up date FNs, this is a collection of different date functions, different date black boxes. If I look at this code, something like format. Where's format? There we go. Here's all this like logic for formatting dates. Don't write that. Somebody else did. Use their black box. Now, you probably have all kinds of things that are super specific. Like, how do we process loan applications? Maybe a loan application is the input, and then the output to that needs to be yes or no. So everything that happens in that, maybe that's the business system. And then one of the smaller boxes inside of that is like, all right, we plug these numbers here. They're compared in the following ways. That generates like a confidence level, or I don't know. You guys know your business better than I do. But like, yeah, that might be another black box. And it might zoom all the way down to, oh, we work on one of the teeny, teeny, tiny black boxes in here that do that, work on doing that as quickly as possible. Because right now, that black box, it takes a minute for that input to turn into that output. So my team works on getting that done faster. Sometimes that becomes a problem even, where you have some team that is working very diligently at making this right there as quick as possible, and boy howdy, have they made it just whip through. The problem is the big black box is the one that we care about. If getting that done doesn't really have that much of an overall impact on how quickly something gets through the entire system, who cares? We call that either a premature optimization or a local optima. Making some little teeny part of it go really fast, even though the thing that's slowing it down is here and here and here and here. Doesn't matter that the little tiny piece was fast. That's part of it too. So yeah, the boxes could be business systems, they could be functions, they could be groups of functions, they could be other programs. If I do my job right, by the end of 16 weeks, all of you will just be thinking in inputs and outputs all the time.
I like the way you rephrased it as far as loans, only because that's where my brain goes. Because it's like we have so many different functions of our credit analysis, but a lot of times we'll see, for those of you who've been in origination, it's like our ARI will break, but that breaks down the whole system. That's the system confidence, but there'll be no, from that, it breaks every part of it in such a little bitty piece.
Yeah.
When that goes down. So it's interesting to think of it that way, because I was like, this makes not much sense, but that helped.
And so, yeah, if the thing that's breaky and slow and whatever else is this pathway through the box, it doesn't matter that you made that really fast. That was the problem. That's what we're trying to make faster. More questions about inputs, outputs, and black boxes.
So if I'm understanding this correctly, the color of the box is pretty much determined on the level of understanding of whoever's looking at the box. Because if you know what the result's supposed to be, but you don't know how it works, that's a black box, right?
Bingo.
And then if you kind of know what's going on, like at least I'll call it 50%, that's like a gray box. If you know everything that's going on in the box, that's a white box.
Sure. Think of it as like the difference between driving a car and driving the car with the hood off.
So is that where like APIs come in if they're using someone else's program?
Ding, 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 ding. 10 points to Gryffindor. Hell yes. Like, so what an API is? An API is an agreement that if you give me these, I will give you these. API stands for Application Programming Interface. This is the interface. It's programming because this isn't a business system. We are sending it code, so that's the programming part of it. And the application part of it is that's what we're using to build applications with. But this interface here is if you give me the EIN and their revenue last year and this other thing, I will give you a Boolean representing whether or not they're approved. That's an API. A function called add that takes in two numbers and returns another number. The API is if you give me two numbers, I will return you their sum. How do I do it? Not important. Black boxed away. Maybe I'm just using the addition operator. Maybe I'm converting it to some other number system. Who knows? And like that's actually not even that ridiculous an example. Let's check this out. So if I write a function called add that takes two numbers and returns just with the number operator or the addition operator. Cool. Man, I don't even need a white box to guess how that's working. Because if I add 1 and 2, I get 3. All right, that sort of makes enough sense. Here's the problem, though. If I try to add 0.1 and 0.1, all right. If I try to add 1, let me see if I can find one of these that is it 0.01. Oh God, why do I always space on this when I'm trying to? This is supposed to be a very dramatic point.
I think you just had it though with that last one, but it corrected because it was like 0.01 plus 0.022.
Oh, it's
it
0.1
added
plus
wrong.
0.2. That's it. It's add 0.1 and 0.2. Oops. Well, that doesn't work. It's because the way that computers work with decimals is way different than how humans work with decimals. There's no concept of a decimal in binary. Decimal is a base 10 idea. So the way that it converts this stuff into binary sometimes results in weird shit like this. So the way that you might fix that is make a better add function that takes in two numbers and returns, maybe do like normalized A is A times 1,000. Const normalized B is B times 1,000. And then sum is normalized A plus normalized B. And then we return the sum divided by 1,000. So maybe we do something like that. And now if I do better add 1 and 2, that still works. If I do better add 0.1 and 0.2, now it can do it. The API didn't change. And I don't need to know that it's not this, it's actually this. Who cares? I care about the API. So if you haven't put this together yet, the real power of this is that we can start by designing the API. We can figure out what we want the black box to be. And as long as, if that becomes a contract, if that's an agreement, I can change the implementation of better add to times 10,000. Oh no, they changed how floating point math works in JavaScript. So it actually works with just the addition operator now. Oh, actually there's a third-party library that, that handles this for me now. Whatever, the API didn't change, just the implementation. So this idea of designing an interface before you figure out how you want to do it, this is critical to problem solving. What are the inputs? What are the outputs? If you don't know those, you have no clue what should happen on the inside.
Can I ask you just a quick question, just because it bugging the heck out of me? What does occur with the previous example? What does occur with the decimal to make it? But what is it doing that makes it do that?
Elsa, come here.
Tiffany, you're not muted.
So
I am so sorry.
you're fine. You're fine. The so what you're doing is, if you look up, I'll post this in Discord. This floating point arithmetic thing. We'll explain it in a little bit more detail. But the general idea is of floating points is that binary only has the concept of like whole numbers. There's no decimals in it. So what you do instead is, instead of writing 32.3, you write 323 decimal point is 1 in. And so then that gets interpreted as 32.3. And the reason it's called floating point is that, imagine like an irrational number, like 6 repeating. Well, there's no way to do that with whole numbers. So at some point, like you have to cut it off. So if you do 6.66666, then you go, okay, well, I'm going to float the point over to this point. But like the wild thing about it is, what if I have a lot over on this side too? So the bigger this number gets, there's only so many like places that I can have on here. So the bigger this number gets, the less precision I can have over here. I know some of you are like video game inclined. So that was what, if you've ever seen people do like hacks on Mario 64, where they like can run infinitely fast on like the edges of the map or something like that. Like that's a floating point math thing. There's a really cool video on that I'll post also. But the idea is that your location on like the map in Mario 64 like uses floating point math. And so as you get further from the center of the map, you lose a lot less precision here. So it's harder to hit blocks. It's harder to jump on people because it can't calculate your position as precisely. Very center of the map, you can do very micro movements. Pretty wild, huh?
Yeah, that's crazy.
More questions about inputs and outputs? All right, let's go through. Oh, this is a perfect one. So this is code analysis exercise number 11. We're going to round robin this one. We'll talk through just how this works. This is part of your success criteria for the reading code unit. So that's step 1. The task is to figure out how the code works. Put in API terms, that's the output. All of this is the input. So I need to turn this into figure out how the code works. Instruction 1, come up with a test input for the function. 2, trace the flow of the program without running the code. Keep track of all the variables and transformations until you can determine the output. Keep coming up with new inputs until you're confident that you know how the function works. And then write a summary of what the function does. So that's what we're being asked to do. First thing is come up with a test input for the function. So I want everybody to take a little bit of time looking at this and see if you can figure out what a good test input to this, I guess it's technically a white box, but what would a decent test input that might give us some idea, some insight into how the code works? Think to yourself for a second. AMP, give it a shot. You don't need to figure out what the code does or anything. Just what is a good input that might give us some insight?
Well, it seems like, you say you don't have to worry about the code, but it looks like it's just determining like a conversion of human years to cats and dogs.
Oh yeah, and I'll tell you right now, that is what this does. So how would we prove that?
So we could put we could put like a human years, 2 years or
awesome.
Plug it in there, and then from there it should, based on the math, it should give us for example, if the actual age is 2, in human years, then in cat years it should be 24. So that should be the result, correct?
You got it. So our test input, that's 2. Why not? So I'm going to take a screenshot of this and let's draw on it.
Just a side note, it looks like you're missing an equal sign under the ifs for actual age.
Where?
For function and then the if statement.
Yeah.
Says actual age.
It's only got 2 equal sign instead of 3.
Oh, that's fine.
Yeah.
This is more, so think of this more as like pseudocode than JavaScript. JavaScript is the only language that does that triple equals thing, by the way. Okay, so AMP suggested 2. So if we put 2 there for actual age, I'm going to call on someone else. Blair, walk me through line by line what the next thing would be.
So if you put 2 there, it'll first go to the would it even go to well, it wouldn't pass the first one anyways.
Okay,
so
pause there. Explain that more.
So it would take the actual age of 2. Mm-hmm. The actual age does not equal 1, so it wouldn't return anything for that.
Bingo.
For me, I just didn't see an else statement, so I didn't know if it would even consider it or how I would phrase that, so I just said it wouldn't pass it, so we're just going to move on.
Cool. Stop there. So that's exactly it. So actual age does not equal 1. So that's false. So if false, then this block of code does not run. You're not required to have else statements. You can have if statements all on their own. So that means none of this happens. Brad, walk me through same thing starting here.
So if you put a 2 in that one, it does equal 2.
Yes.
So it's going to return the actual age of 2.
Cool. So that means that gets replaced with that, and then my output is this object.
Okay. So is it going to multiply the 2 times 24, come up with 48, or?
Ooh, that's a good question. Who can answer that? This stuff down here.
It will not.
Why not?
It just returns 24 for each, because any number, it would be 0 for both of those. Actual age minus 2 is 0.
So this return, that means it's over.
Yeah.
We don't do any of the rest of this. That doesn't end up running.
Oh, because that's all it's supposed to return.
Yeah.
So is that the formula, or that's just what, it's just like a red herring type thing, just throw you off?
Not necessarily. So
If
Julie,
a statement is true, that ends the coding, right?
Yep.
Okay.
So this return keyword means that the function's over. And the function evaluates to whatever this is. So is this other thing a red herring? It's a good question. So let's try this with another input. Julie, give me another input.
10.
Cool. So that becomes 10. And then Andy, walk me through what happens starting at the first line.
Sure. So it's going to take the number 10 and it's going to go to if this actual age equals 1, it does not. So it's going to stop there and it's going to go down to the next if statement. If the actual age is equal to 2, which it does not, so it's going to not return that. And then it's going to jump down to the next statement there. And if the actual age is 10, and then it is going to perform those functions.
Walk me through them.
So human years is 10, then cat years, it's going to do 10 minus 2, or 8, and then multiply it by 4, so 32, plus 24, which is 56. And then dog years, it's gonna be the same result, and then it's gonna return that it's gonna return the human years, cat years, and dog years at the end. So 10, 56, and 64.
Yep.
Oh, I didn't see.
Correct. That's how this works. That's programming in a nutshell.
So that works because there is no if statement. So the function at the top translates all the way down until the end of the curly bracket.
Right. Since we had two conditions on here, but both of them were false, these blocks never run. This doesn't have any condition on it.
Because there's nothing. Okay.
And it evaluates it, but it doesn't do anything as far as printing it because we haven't told it to print or anything, right?
Yes. So this function doesn't have a name, but if it did have a name and I called it with 10, that is exactly what it would evaluate to. So if we called this like get years and passed in 10, this expression is interchangeable with human years, that whole object. So it's almost like we hard-coded out this entire object, but we didn't have to because we could call that function. So, come up with the test input for the function. Trace the flow of the program with the test input without running the code. check. Keep track of all the variables and transformations until you can determine the output. That's what that looks like. That's what tracing the variables and their transformations. We're replacing these parameters, the theoretical values, with the actual values, the arguments that we gave it over here. Keep coming up with new inputs until you're confident that you know how the function works. And then write a summary of what the function does. So figure out how this code works. That's the form that that takes. So if we're following the instructions, let's see, Scott, give it a crack. Describe what this function does.
This function takes an input of actual age and will give you a return, or give you an output, pardon me, that shows the actual age in human years and the conversion into cat years and dog years.
Cool. So if you're doing that assignment, I want that over here, and I want an input-output table showing that you tried running this with different things.
Would we also want to note that if the input is either 1 or 2, it's hard-coded to give the answers of 15 and 24, respectively?
But it's not giving you 15 and 24. It's giving you those objects. And so what you could do is say, all right, if it's 1, I get this hard-coded object back. If it's 2, I get this one back. And this is a huge part of being a programmer. Like 3 might be, that's fine. I would take that. But you don't also need 4. You don't also need 10. You don't also need 20. We'll talk in our next unit about a concept called equivalence partitioning. But we want test inputs that give us new information. So 1, 2, and 3, or 1, 2, and 10, I would take any of those as inputs. Also, I'd kind of be curious, what happens if we do 0? What happens if we do weird stuff? Where'd that go? This. So if I do 0, is 0 1? No, it's not. Is 0 2? No, it's not. All right. Well, then human years was 0. That's 0. That's 0. So -2, -2. -2 times 4 is -8. -2 times 5 is -10. Plus 24. So that's going to be 16 and 14. So is a 0-year-old human 16 in cat years and 14 in dog years? I don't know. I don't know if that makes any sense. So like, that's how bugs happen in programs. Because like until then, it'd probably be even worse with -1. But like -1 can't be an age, right? Nobody's -1 years old. So how does that get accounted for? Do you check to see that it's a positive integer and kick it back? Anyway, that's where programming starts getting complicated. That's looking
so correcting that would be adding an if function for actual age is greater than 0 or something?
Totally. Or you can make a reasonable case that, the function should just trust that it's a positive integer. So we're doing that if statement before we call it rather than inside the function. But like those are the kinds of decisions that you make a lot. And that's a good example of looking for the gorilla while people are passing basketballs back and forth. We need to think of it like a computer. Computer doesn't understand what age is. It doesn't know what a dog year is. This stuff is for us. That's for us to read. To the computer, it's all just beeps and boops. So the computer doesn't know that somebody can't be -1 years old. I don't know, it just said give me a number. -1's a number. 2.3 is a number. Do decimals work on this? Maybe.
I have a question, Kyle.
Yeah.
For like a real life scenario of something like this, would the actual age call to a different area where someone can actually type in their input? And then so whatever someone would type in would fill to actual age? We don't go in and change it to 10 to 5 every time, right?
Ah, what a wonderful question. Inputs and outputs. So the input to this, to the big system, might be typed age, and then the output is all ages. So you probably need some kind of box to capture that input. So maybe that's the HTML part of it. So I've got an HTML thing here that is capturing the thing that they're typing in, and then it takes that and passes it to the function that we just wrote, and then passes that output to the outside. So this function doesn't also need to be concerned with how it gets the age. It doesn't give a shit. All it cares about is that I was given an age. And then similarly, this thing goes, I don't know what you do with an age. It's all my job is to capture it. And then I was told I was supposed to give it over to this get ages function. I don't know what they do with it. I just know that that was the input that they wanted. And then that turns into all of the ages as the output. But that's how we decompose problems in programming. We make boxes that pass things into boxes that pass things into boxes. Hey, where have we heard that before? Somewhere in Unit 1, we had the exact same conversation.
The command line?
Yeah, what about the command line?
Isn't it paths?
What was that?
Isn't it paths?
Is it apps?
Paths. Paths. P-A-T-H-S.
Oh,
H-S,
no.
Yeah.
Not patch. What on the command line does this exact same thing, where we're just passing inputs into outputs into inputs and inputs into outputs?
And for the different commands.
All
like
the different commands. So when you have your cat sum file going into search for something, going into get the word count. Ta-da! So yeah, when I was I did that word count thing the other day for the curriculum. Oh, it is here. So if I do something like, hey, give me the text of everything that ends in .md, and then take that output and count all the words in it. Outputs into inputs. All software. More questions about this? Cool. So, where we go with this Once you're confident with reading code, then we start writing some code. And I'm starting with just some real, like, bread and butter JavaScript things that you will do the rest of your career. Which means I'm skipping a lot of things that are almost always in introductory programming things, like for loops and while loops and switch statements and a bunch of shit that, like, you don't need to do for the next couple weeks. These are the things that, like, are going to be your, like, bread and butter coding stuff. So we're gonna get to all the other stuff in the next unit, but we're starting here. You work on the web, this is the stuff you're doing day in, day out. So once you can do that, that's when we start integrating this with all the stuff we did in the last unit. So we've talked about how we could sort of think of like those HTML files as trees. So we got an HTML root, has a head and a body. We've got the script tag and a link tag and a title and a character set. And this has a header. And this has a main, and main has a p tag. All right, so this whole thing here. But we write it out in that file with the angle brackets and stuff. So that file that we take in, that is instructions on how to, for your browser, on how to build this tree. Once your browser has built this tree out, now you can use JavaScript to do stuff with it. For example, I open up the console. I want to change the name of this thing. So this is Curriculum Contents H1. I can say, hey, give me that H1. Document, query selector. Come on, dude, type. And shoot, I already lost it. It was curriculum-contents H1. This should probably be an H2. Curriculum contents H1. Hey, there we go. All right, so I've grabbed that element. Now I can do stuff with it. I could say, never mind. I want the text content of that to be DOM elements suck. I just did something with the page. Now, what I really want to do is only do that when somebody clicks a button. Okay? So what if I take the body, and I make a button, and I set the text of the button to wake up, sheeple. And then I put that button, body.append. What if I put that button on the page? Hey, there's a button there now. If I add an event listener for that button, it says, hey, whenever this gets clicked, grab the heading, curriculum content H1, and that's what I want you. Only when someone's ready to hear the truth about the DOM, that the text content of that should be the DOM is a lie. Oops. That is right. It needs to know which event that I want to listen to. All right, so DOM elements, a likely story. That's DOM manipulation. So we're using JavaScript, we're using the stuff that are ABCs, and we're using them to make the page interactive. So that's... Stop it! Stop it! It's following me everywhere. So that's the DOM stuff. The API integration and the form stuff is if I have an external API, like say the Pokemon API, and I want to use some stuff from the Pokemon API in my page, then I could maybe do something like let's see, I'm going to fetch from pokeapi.co/api/v2/Pokemon/Pikachu. Can you tell that I've used this API before? Once or twice. And then whenever, so that's going to send an HTTP request for some data. And then whenever the response comes back, I'm going to parse it. It's going to give me JSON. I'm going to turn it into a JavaScript object. And then I'm going to take Pikachu and then I'm going to make a new image tag. Document create element image. I'm going to set the source of that image to Pikachu.sprites.front_default. And then I am going to append that to the body. Actually, front default, Pikachu deserves better than that. Let's do front shiny. Look at him. That's not my code. I don't have a Pikachu GIF anywhere. These people maintain a black box for me. And whenever I request something from the black box, the input is a name. The output is all this data. Now I can do stuff with that data. I have no clue how they do. Oh, that's not true. It's open source. But I was going to say, there's no good reason for me to have a good idea of how they do this. I don't know what language this server is in. I don't know the licensing. None of that. All that is opaque. That's in the black box. All I know is if I make an HTTP request to this URL, it gives me back all of this stuff, which includes URLs where I can get images of the Pokemon.
Well, I have a quick question for you.
Yeah.
In that first example, you grabbed the H1 element and saved it to a constant variable, and then you were able to change it. And I don't see why you were able to change that constant variable.
That's a super good question. It's because I didn't. Const isn't that you can't change it. It's that you can't reassign it. I never reassigned it. I called something on it. I did something like this, but I didn't assign H1 to anything different. So if I have some variable and I say that it's 1, and then I try to make it 2, that's an error. If I make an object that has something in it, I can make b.age equal to 2.
Oh.
What I can't do is change what b is.
I see. Okay, that makes sense. Awesome.
Just real quick. So when you connected to the URL then
Mhm.
for the Pikachu for the API, that's another example of that, like the article we read, where if they decided they don't want to share Pikachu with the world anymore and they dumped it or blocked it, it would fail in your code, right?
My app breaks.
Okay.
So, for example, when Twitter had a really powerful API that you could do things like create your own Twitter clients for, and remember when TweetDeck was a thing, and there were all those different Twitter clients? That's because Twitter made it so that you could either go to their website and use their app that way, or you could they exposed all of these kinds of endpoints that would let you read your feed or post a tweet or do any other thing. So you could make your own client for interacting with Twitter. And a lot of people made businesses based around that. They're like, oh, no, man, don't use the actual Twitter client. Use TweetDeck. Use whatever all the other ones were. And some of them would do other things like, you can post one time and we'll use the Twitter and Facebook and MySpace APIs or whatever, and we'll post them all to all of those places at the same time. And then one day Twitter went, never mind, we want everybody to go back to using our app. And they shut down those APIs and all those companies went out of business. That can happen.
Seems like it wouldn't be that good of an idea to depend on too many APIs in that case if they decide to change their minds and not do it anymore.
So the business case on that is all right, our entire business is dependent on the willingness of Twitter to keep maintaining this API. That would give me pause. I don't know why any of those people ever someone got funding. I don't know why anyone would give them money. That was a risky endeavor. Pokemon API, that's a different kind of risk. Because if my risk on the Poke API is this goes down, all right, well, I can just start maintaining the data myself. I can see that if somebody runs a competing Poke API. Also, it was a big part of this is that all this is open source. So let's see if I can find the GitHub page for it. Over here, there we go. So here's all the source code for it. If this person doesn't want to maintain it anymore, if they want to, if they pull it down, whatever, what's the licensing on this? BSD? I can do almost anything I want on it. I just can't sue them if that's not what Pikachu looks like. And so cool. I fork it and I make my own version of it, or I make my own modified version of it because I'm allowed to. I go, I refuse to recognize the legitimacy of Pokemon Red, something like that. So that's a lower risk than Twitter shutting down their APIs. And then there's stuff where there's like weather APIs. There's tons of those. If one of them isn't working out for you, swap it out for a different one. And that might end up being, all right, I want to know whether or not I should wear a hat today. So I put in my location and I want a yes or no on whether or not I should wear a hat. And so if the black box in here is go to the weather API, and oh no, that weather API sucks, or there's a better one, or they shut it down, or whatever, cool. You move the internal box, the overall app didn't change at all. And anybody using the black box doesn't know that you changed how it worked. They don't care.
So what if I had used the weather API and some disgruntled coder went into their API and was changed it to say, just stand outside, asshat, and then my website then uses that as its output? Wow, that's
correct.
Fun.
Like, or it might be like how every time AWS US East 2 goes down, half the internet goes down. Like, it's a very interdependent system. Because the alternative is write all of this stuff from scratch yourself. And so while you're still doing that, entire business cycles happen.
How is the Poca API not being sued? Are they protected under Creative Commons license? Because, I mean, they're using all of Nintendo's images for the most part.
Even if they were, Matt, you and I both know Nintendo doesn't care. Nintendo just doesn't know about them yet. That's the only answer I got.
Actually, Nintendo is super litigious.
Yeah.
But I believe that, there we go. That's why. It's an educational tool. So that gets them under fair use, being purely educational. Because, like, I can do this to teach a class with y'all, and I've done that before. If I was actually using this for a commercial Pokemon product, they'd ban my IP address. Because they know what my IP address is, right? Because I made the request. So they can go, this dude isn't teaching a class. This dude is trying to run some commercial server on this. And so they go, cool, any request coming from that IP address, denied.
But can't you just change your IP address? Not like, I don't want to sound like shitty life pro tips over here or anything, but.
Oh, you absolutely can. How about, like, if that's your commercial service, which is the thing that's getting you banned in the first place, how much downtime between that? So you lose an hour, like, every other hour as they continue to ban you? And, like, getting a new IP address, like, that's not a fast process. So it ends up just being a non-starter for getting around something like that. There has been instances, too, where, like, so we know that as far as the internet can see, my local IP address, that's not what the internet sees. So, like, I'm 192.168.150 or 0.150. That's my local IP address. My router, that IP address, so, like, that's the one that the Poke API sees. Now imagine, like, I'm in an office building or something. Can anybody put together why this is, like, super risky?
Because you all have the same.
Like the company.
Yeah, you got it. Like, everybody in the building has the same IP address. So if you get banned by the Poke API, the entire building is banned from the Poke API. Oops. And that absolutely happens. Duct tape and string and spit. Like, it is not a, like, it's honestly, I think it's beautiful, but it is very anarchic. So
it's crazy that it's not more of an issue. Like, it just
right?
works most of the time.
Right? So that's the shape of the next couple weeks of our lives. Reading code, learning how to make the websites that we made in the first unit interactive, integrating them with external stuff. And then we'll also learn how to capture user input from forms and use that to be part of it. So that you could do stuff like I want to search for a Pokemon. And so a user types in something and then it goes out and gets that one. And so at the end of this is the production website. This one's a lot like the implement wireframe one, except much more involved. So I don't think anybody will be able to knock this out in a day. And just like in the first unit, we'll have group stuff and we'll have light days and all that sort of stuff. But where we end this unit is folks doing an API integration and like making a for real web app. And that's the shape of it. Questions?
This was super timely because I was going to ask you how the Ford website put their social media links up, and this explains it. They were using the APIs.
Bingo. I'm trying to think of some other like super obvious APIs. Big list of APIs. Here's an example of like the kinds of things that you can get from these. Oh man, the students love this one. It's like IMDb, but it's open source and it's an API. So you can make your own IMDb. Recipes, memes, news. So like you could have a news feed or something. Random facts. Finance stuff, football scores, tons and tons. The Untapped, the keeping track of your beers. You can make your own front end for that. Or the wildest ones. I think like some of the coolest API stuff on the web right now is all Watson. It's not free, but check these out.
Watson as in the AI?
Watson is in the supercomputer.
Crazy.
So, like, you can rent time on Watson. And the kinds of things that you can have Watson do are pretty wild. Speech to text and text to speech. So you want to process... is the tone... and it also has the tone analyzer. You could plug these two together. You could play back like the audio from an episode, send that into the speech to text analyzer, take the text that you get from that, analyze the tone, and figure out what the mood of that episode was by renting time on Watson. Natural language understanding. You want to make a chatbot? You want to make an Alexa skill, something like that. How do you understand all the different ways that somebody might say something? Use the natural language API, and Watson will try to make a guess at giving you that information and like something you can plug into a function. It's wild. Like, the internet is so cool. Anyway, that's pretty much what I want to talk to you about this morning. What questions do you have?
Is it common for there to be costs associated with? I know there's a bunch of free APIs and stuff like that, but obviously the big one like Watson, there's cost associated with that. Is there a lot of big companies that try and do that rent out their time?
Like, there's a lot of companies that have figured out that why are we maintaining this data? The data is the valuable part of the company, and we also have to maintain the app for it? Well, that's stupid. What if we just charged for access to the data and let other people build the app? That was really common. There are a couple things that like there are no good free APIs for and never will be. Good example, stock prices. There are stock APIs, but they're slow. Like they're at like 1 minute intervals and stuff. So if what you really wanted to do was do programmatic trading, where like it's analyzing conditions or shit, you could even plug that into that sentiment analysis from Watson. All right, what companies are in the news and what is the mood about those companies? You can programmatically like buy and sell shares and stuff based on that. So like all the free APIs are too slow for that. There are a ton of competing APIs that try to get that down to like milliseconds and stuff of how often those prices are being updated. And so algorithmic traders, yeah, all those APIs are like, they're also super expensive. And there's a couple of, the more niche it is, the more likely it is to be super expensive too.
For the ones that do have the fee, what does the fee structure usually look like? Is it something that it's based on traffic, or is it based on just like a flat fee, like monthly, or?
How many times do you use the black box? So and a lot of times they'll bucket it too. Like you get 10,000 requests for free, and then every request between this amount and this amount costs this much, and so on. And sometimes they'll let you throttle it. So like if you get attacked, like that's one of the reasons that somebody would attack a site is to try to rack up their like API bills. And so you go, oh, and if it goes over 10,000, I don't want it anymore. Just shut me down. I'd rather have my app broken.
That kind of common sense thinking when it comes to using these APIs, is that something we'd be going over, or could you recommend a good source for us to go to externally?
We're going to talk about APIs quite a bit.
Okay.
And you'll do a lot of projects with them throughout the program. You'll get a sense of how this works. But there's nothing you do in the program like requires using paid APIs.
So when an app breaks, like the forward pass broke and all the data as a user was deleted,
Whoa.
Is that probably because of an AIP? In order to even get my car back on there, I have to reset my car. And I'm like, fuck that. I'm not doing that.
Happened a lot of times too.
Wow, that has nothing to do with APIs. That's just bad program design.
Oh, okay.
When something goes down, it shouldn't also delete all the data. Like,
Oh no,
those are unrelated problems.
Okay.
That's why they're looking to train new people.
That's the first thing I want to fix because I do not want to reset my car. And it's an intelligent system, but I don't want to reset my car.
Sure.
I just don't want to do it.
Yeah, something's connectivity and something's like stored data should be unrelated problems. Doesn't mean they always are, but. Other questions about inputs, outputs, what we're doing the next couple weeks?
So just do you have a suggestion as far as reading the code? I'm not sure it's in the actual part of the program, but like when you're reading the code, do you do it in a certain manner, like the document query, you look from right to left, like you told us to look at
Sure.
some of the other stuff? Okay.
All that stuff is in the curriculum, and my best advice, think about the gorilla, think about the GitHub reading thing from this morning. Real slow, one line at a time. Because all of the code in this first part is what we call procedural code, which means it starts at the top and runs at the bottom. Not all code does that. Some of it jumps around a little bit, but procedural code kind of doesn't. So like it's where everybody starts with this because you can just go, well, it's this, and then it's this, and then it's this. And also, like, I'd highly recommend doing what I did where you draw on the parameters and stuff of what their values are right now. When I'm trying to figure something out, especially if I'm trying to debug it, like, that's not just a thing I'm doing for the lesson. That's like a very normal, like, okay, I need to trace the flow through this. This was a 2, and then this checked whether or not it was a 4, and it wasn't a 4. And so then that actually skips past this block. That is like troubleshooting 101 stuff. And should you ever find yourself doing a job interview where they make you live code or whiteboard or something like that, like that's the trick for that, is figure out your inputs and outputs, and then one step at a time, like walk through what things do, what what the current state of a variable is, all that kind of stuff. And if you do that enough times, your brain starts to think like a computer. Other questions? Have a good lunch. See you in an hour.